So H and K, if you recall, on a graph for absolute value, H and K was the point of change, wasn't it? Right? That right there would be the H comma K value. Do you remember that? Okay? And then the A kind of determined if it was skinny or fat or if it was up or down. Remember that? Okay? So we have the same type of concept with the vertex form of a quadratic equation. The A, the H, and the K represent a very similar feature. Okay?
Is the HK like the maximum?
Okay? So we have here A and then parentheses H minus K squared plus K. A, when you have the value in front of that, tells us the width of the curve and then the direction. Okay? So, depending on what the A is, it could be super skinny and up, or super skinny and down, or it could be fat and up, or it could be fat and down. And we're going to look at how we can tell what that is in just a second, okay? The H value, okay, is going to tell you the horizontal transition. I'll say translation. Okay? So just like if you can recall, when we were working with the absolute value, the H moved us this left or right, correct? Well, the same thing with our vertex form of parabola, it moves us left or right on the axis, okay? Your K is going to, and that'll be left and right that way, our K is going to tell us the vertical translation, okay, and which means up or down, okay? Because now all our curves are in the middle of our graph, are they? Some of them are, if we have a graph here, some of them are like down here, some are up here, right? Some are skinny and some are fat. And that's all because of the A, the H, and the K. You'll move it, change it, okay? All right, so to graph the vertex form, okay, you want to find the vertex, which are H or K, and then the direction of opening, and then 4 other points. And so we'll use our T-chart for that, okay? So just like with our absolute value, you have to take the opposite of what's inside the parentheses for H, right? So remember how it was like -2, or H was going to be a +2? If it was x plus 2, then our H was a -2. It's always the opposite value, okay? All right, so we want to find the vertex, find our direction of opening, and find 4 other points, okay? So if you look at this example here, this is an example of vertex form. If you notice, it has a value in front of parentheses squared plus a value, right? That's vertex form. So, what is A in this situation? It is -2. What is B? I'm sorry, H. I'm all going straight into A, B, C. What is H? It is 3. It is a +3, because remember it's the opposite, right? Okay? And then what is K? It is 4. Okay? So, if I tell you that my vertex is going to be H and K, okay, what is my vertex? 3, 4. So now you don't have to actually do that formula. You could just look here and pull it out, and actually that's your vertex.
Why do you not solve that first? That equation.
Why do I not put it in the standard form?
Yes.
Because I don't have to. Because if I did, you'd have to go to the way of graphing that we just did. But by this way, though, it's a little bit simpler in regards to getting there. Okay? You can, but you could just look at this and know what your vertex is just by those 2 numbers. Okay? So then I can plot that, right? So I can go over here and go 3 and then go up to 4 and plot that, right? Okay, I'm going to look at my A, okay? What does A tell me? Is it opening up or opening down? It's going to open down, right? Because it's a -2. So we know it's going to open down, okay? All right, what's my axis of symmetry? Well, I don't have to plug it in. I can just know that the axis of symmetry is always the x value of my vertex. It just means what line does my parabola go around, okay? So that's my axis of symmetry. Okay? So then what is my domain? What is my domain? What is the domain of all these parabolas?
All real.
It is all real. Okay? Well, what is my range going to be? Now we know it opens down, right? So that's a maximum, right? So therefore, y is going to be less than or greater than that value. Less than or equal to than whatever y is. Okay? And we know that it's a max. Okay? So that's right there, everything we can do so far. So to find the actual couple points to plot, okay, I'm going to do my vertex in the middle, so 3, 4. Vertex should always go in the middle of your T-chart. And then I'll just do 2 up and 2 below. So I'll go 4 and 5, and then I'll go 2 and 1. So your vertex is always the middle point. Vertex is always middle. Okay? Vertex is always the middle point. If I put in, let's say, 2, so I'm going to do -2, and then I'm going to have 2 minus 3. So all I do is take this value and plug it in for x and solve. Okay, so that's all I'm doing. So I have -2, so 2 minus 3 is -1 squared, which is 1, times a -2 is -2, plus 4, that's going to be a positive 2. Okay, so I have a point of 2, 2. Right? So I can go here, and I can go 2, and I can go 2. Well, what do I know about one side and the other side? It's the same, so 4 should be 2 as well. Okay? So 4 should be 2. Alright, so then let's do 1. So I'm going to have -2, I'll have 1 minus 3 squared plus 4. So that's going to be -2 squared, which is 4. 4 times a -8 is -8. Or 4 times, yeah, -2 is -8, and then plus 4 becomes a -4. Okay, so I can go 1, and then go all the way down to -4. Okay, so what would 5 be? -4.
So what does A have to do with it?
You're going to see and decide. It makes it skinnier or wider.
I know.
So the bigger, what's that?
Mm.
You'll see. Alright, so now you could connect them like this, and then you can kind of see what your curve looks like. Okay? So again, just to kind of show you, to make sure that we see this, I'm going to do a different color. I don't know if that makes a difference or not, but just up at this vertex form here, okay, this is always going to be H, and it's always the opposite sign, okay, and this is going to be K, and then the H comma K equals your vertex. Okay, so I just want to kind of show that. Alright? Alright. Questions so far? Alright, why don't you guys practice, try this one here. What you want to do then is name the vertex, the axis of symmetry, your domain and range, okay? And you'll know your range base if it's a minimum or maximum, okay? And you want to find 4 additional points, okay? So 4 additional points. Okay? So go ahead and try that one on your own. Alright, so on this one here, the vertex is going to be, again, this is your H and K, right? But the H is the opposite, so my vertex is going to be -3, comma, -2. So I can plot that all the way down here. Okay? My axis of symmetry is x equals -3. You guys, when it says axis of symmetry, it's looking for x equals something, meaning it's an actual line, okay? It's an axis, okay? If you just put -3, that is not going to be 100%. All right, so then, what's my domain? All real. What's my range?
Y is greater than or equal to -3.
Yeah, so to know what your range is, you guys, you have to know if it's a minimum or maximum, because you have to see which way it opens up and then what y values satisfy that. Because A is positive, it opens up, so that's going to be a minimum, right? So therefore, your y values are this and greater than. So it's going to be y is greater than or equal to -2. Okay? Alright, then we did -3, -2, -4, -5, and then -2, -1, which kind of could have had it reversed for all. I don't know why I went that way, but anyway. If you did -2, you should have gotten 2, which means -4 is 2.
14.
Okay, so -2 is going to be 2. And then that means -4 is going to be 2. And then I got -1 is 14, and -5 is 14. So a -5 you can go all the way up to 14, which is like way up here. So it's like a skinny graph. So you can kind of go like this. Okay? Questions on that? Good? Alright. Thing. We have it where you've been given the vertex and you've been given an x-intercept of 4 and it wants you to actually create the equation. So now we're going to work our way back. Just like when you had x equals 3 and x equals 4, you were able to put the two factors together and work your way back to the actual quadratic. When you have a vertex form, you can do the same thing. Okay? So if we have vertex of 3 and -2, okay, what does 3 represent? It represents h, and what does k -2 represent? K. I always give you guys the answers, right? Okay. So I know that my h equals 3 and my k equals -2, correct? And I know that x equals 4. When it equals h equals 3, but we're going to plug it into the equation, which will make it negative. Okay? Right. So x, when it says x-intercept of 4, it means x equals 4, right? That's what an x-intercept is. So I know those bits of pieces of information, right? So if I tell you, okay guys, you need to create an equation, I'm going to plug in the things that I know, okay? And then solve for the things I don't know, okay? So I'm going to plug in, I know I have y equals a x minus h plus k. That is the vertex form, right? So when I want to write an equation, so I'm just going to do this off to the side. So write equation. Okay. Number 1 is you want to plug into the h, yeah?
Isn't it a x minus h squared?
Oh, squared, yes, squared. Squared, sorry. And I will do that 100 times, so yell at me. I do it on purpose, so you're paying attention. Seriously, no, I will. Alright, so then we have to plug into your hk into the equation, into the vertex form.
So you just solve it with x equals?
Okay?
Oh, yeah.
So, I'm going to plug in what I know. Well, right now I have y equals a x minus 3. I'm going to substitute the h. Hold on, we're not going to go there yet. I'll get there. Okay? I'm going to plug in the 3 for the h, and then I'm going to plug in squared, and I'm going to plug in then the 4 for the k. Okay? Oh, -2. I'm sorry, I just saw that right there. Sorry. I just looked at the 4, saw the 4. -2. So it's -2. Okay? So I take my h, plug it in, take my k and plug it in. Now, number 2 is I want to plug in the point I know. Plug in the point I know. Okay? I know that x is 4. What is y when x is 4? 0. So I know x is 4, therefore y is 0, right? So I have an x and a y coordinate right now. This is actually becomes, then this is 4, 0, right? And that's an x and a y. So I can take that value and I can plug that in here. Right? So I'm going to do that. I'm going to 0 equals a 4 minus 3 squared minus 2. So at this point then, I'm going to, number 3, solve for a. Because that's the unknown, right? So that's become 0 equals 4 minus 3 squared is just a, because it's 1, so a times 1 minus 2, which is just really a minus 2. Okay, and then that then becomes a equals 2. Okay, so this is number 1 here. This is number 2 here. And this is number 3 there. So then I combine that, becomes 1, so that's just a, and it's minus 2, add the 2 to both sides, a is 2. Good? So now I have an a, where a equals 2, I know h equals 3, and I know k equals negative 2. So now I can take those 3 elements and actually plug it in to create the equation. So it's y equals 2, and it's going to be x minus 3 squared minus 2. Okay? So then you just rewrite, number 4 is rewrite using a, h, and k. Alright, and so this is number 4. Good? Okay? So, good so far? Alright, so now, on these you have graphs, you guys. Now, on the graphs, what I'm giving you is, let's look at the information we know. So if I look at A, right here, this one here, what bits of information do I know?
Vertex.
Alright, what's the vertex?
3, 2, 3.
2, 3, right? So what is H?
2.
What is K?
3.
Alright, what other bit of information do I need to know to try and write an equation? I need a point, correct? Is there any point on here I could use?
0.
0, 7? Okay, let's use 0, 7. So now I have x is 0, y is 7. So what you need is you need an h and a k and a point, and any point can be plugged in to solve for a, right? So now I'll just plug it in. So I would do 7 equals, okay, and then I'm going to have a, because I still don't know a, I would do 0 minus 2 squared plus 3. Okay, so all I have my h and my k, and I plug in the point that I do know. So then I would get 7 equals, negative 2 squared is 4, so I have 4a plus 3. So I subtract the 3 to both sides, I'm going to get 4 equals 4a. What does a equal? It equals 1. So now I have an a, so a is 1, h is 2, and k is 3. Can I write the equation now? Okay, so I'm going to have y equals, a is just 1. You could write 1 or just leave it. Either way is fine. I'll do 1, and then parentheses, x minus 2 squared plus 3. Okay, so when you're trying to solve, you need h and k, which is your vertex, and then you need a point. And then you plug in your point for x and y right there, solve for a, and then substitute it back in to create the equation. Okay? Does that make sense? Alright, you guys practice B for me. Practice B. So on this one here, our vertex is what point? Negative 3, comma, negative 1. Okay? So that means my h is negative 3 and my k is negative 1. Okay? So now I'm going to plug it in. I got y equals a x minus your h, which is plus 3 squared minus 1.
If we want to change the magnitude from the vertex to h, you just have plus 3.
No, when you are taking the vertex, you are taking h. It's when you're going from the equation to find the vertex, you go opposite. Because the equation is y equals ax minus h plus k. So,
But when we write down h equals 2, it's changed.
no, because h is, you guys, your vertex point. Okay, don't change the value of h at your vertex point. It changes when you plug it into the equation, because the equation says minus your h value. Does that make sense? If you say h is 3 here, then when you go to subtract it, you're going to have x minus 3 versus x plus 3. Does that make sense? Okay. So, good on substituting h into this equation. Then I plug in my x and my y. So, when you're looking at a graph, you guys, you have to find a point that's like a good point as best you can, because they're not necessarily going to be exact. So, you want to find one that's like super close. So, if I look here, we said -2, -1 was a good one, or -2, 1 was a good one, right? It was like kind of right at a cross point, so try and find that. So, I'll use -2, 1. So, I just plug it in. So, 1 equals a -2 plus 3 squared minus 1. So that becomes 1 equals, well, 1 squared is 1, so a minus 1, so a equals 2. Right? And so when I plug those values in, I get y equals 2, x plus 3 squared minus 1. And that becomes the equation.
So where did you get the -2?
The -2 one, I just found a point. Like, there was a point I picked.
That you thought was
So,
wrong?
that way I just found one that looked good. Like, this looked like it crossed an actual, like I could have done -4 in one and then get the same answer. I could have done -1, 6 and gotten an answer and just plugged it in. Okay? Okay, so again, you find your A, B, and C. You find your vertex, -b over 2a. That's going to be 12, -12 over 2 times 2, which is -3. -12 divided by 4 is -3. You take -3 and plug it back in. When I take -3 and plug it back in, I'm going to get 9 times 2, which is 18. 18 minus 30, is that what you guys got? 36? Okay, so I take my -3 and I plug it in, right?
Yeah.
So 2 times -3 squared plus 12 times -3 plus 7. So 9 times 2 is 18. So 18 minus 36 is 18, a -18, right? And then plus 7, which is -11. So my vertex is going to be -3, -11, right? That's my H, that's my K. Oops. Okay. So my y-coordinate is going to be, I know a point, because I know my y-coordinate is 0, C, which equals 0, 7. So now I have an x and a y, don't I? So now I can plug it all in. So I got 7 equals 0, A, and that's going to be 0 minus a -3, which is plus 3 squared, and that's going to be minus 11. Does that make sense? So I did? Okay, so then I got 3 squared, which is 9, so this is 9a equals 7 minus 11. So add 11, so that's 18, equals 9a, so what does a equal? 2. So I have an A, I have an H, I have a K. So now you write your equation, y equals 2x minus -3, which is plus 3 squared, minus 11. Okay? Does that make sense? So this is just follow the directions. 1, 2, 3. Actually, I would put in between these two, solve for A, and then plug in. So I'd make that 3.5, and then make that 4. Okay? Yes? Oh, yeah, I guess I could have done that. Duh.
Are you kidding me?
Well, I just proved to you how A works. Okay?
Are you kidding me?
So is it the same A?
It is the same A.
The A is
Yeah.
Kidding me?
So we could do for the next one, we could do
Yeah.
negative 1
So
over
we don't,
A.
so technically we don't have to do any of that.
What?
Right, technically you don't need to do this right here.
If you showed us that on a test, we would not have to do the work.
No. On this one here, you don't, no. You just plug in the A that's right there.
For the you try one, either.
Okay, so you guys try it without solving for A.
Negative 1.
No, it's not.
So negative 1. Yep, A is just, that's A.
What did I get a vertex? Did you guys get anything?
So negative 1.
So negative B over 2A is going to be negative 4 over negative 2, which is in a positive 2. And then when you plug that in, what you guys get?
2.
Negative 1.
HK.
Okay, so your vertex is 2 comma negative 1. Okay, so now that's your H and your K. So my A is what? A is negative 1. My H is 2 and my K is negative 1. So plug that into your equation.
How's the H 2? I know that the X is 2.
Well, that your X, this is your X and Y become your H and K.
X and Y become H and K.
Uh-huh.
X.
So then you would have Y equals negative X minus 2 squared minus 1.
I thought that H and K were